Now about the main components and the connections. First of all, we are using the MPU 6050 to control the movements of our robot. This model is connected to the analog pin number 4 and the analog pin number 5 from the Arduino. Another component we are using is the Bluetooth model HC05. This model we are using to control the car without using cables. This component is connected to the pin number 0 and the number 1 from the Arduino. And another model we are using is the L289N. This is an H-bridge that we are using to control two motor reductors that gives the movement or the torque for this project to make the car to move. This model is connected from the 5th pin to the 10th, and these are basically the main components we are using to control this project.
We used this program in the previous RA to calculate the MPU offsets, which is basically what the program is about. First, the program resets the offsets and then gives it to us through the serial monitor. The communication between the MPU and the serial monitor is like 150,200 baud. And to show us the messages, first we have to type any character and start the calibration sketch. And it has to be horizontal and without moving the MPU for the connection to be stable. Well, offsets each one correspond as this is declared, like ACE IX, ACE IY, ACE IZ, and turn Y, turn Z. The connection was good.
I'm going to explain the programming code and the function of the balancing robot. Let's see the computer first. Here we have the code to the balancing robot. We use some libraries, as we can see at the first lines. The PID to control the motors, and the MPU. Then we declare all the variables to the bridge edge, L298N, and to the pins to the Arduino. Here we have the variables to KP, KD, and KI. All these instructions is to control the balancing motors and first the MPU. Then after that, controlling all the PID, we have the void loop to the Bluetooth. And here are all the instructions for the Bluetooth and all the characters that will be sending using a phone. Okay, I'm going to put the battery on the Arduino. We couldn't make it too precise. Okay. Here's the balancing robot. As you can see, it's not too precise because I'm trying to put in line, but I'm going to put in the base, and we can see it's difficult to keep in stability, as we can see. In this part, we have the NPU with the light on, and we have how is blinking the LED of the Bluetooth. We download this app. It's called Bluetooth Serial Controller to control the Bluetooth. We turn on the Bluetooth cell phone. The trouble here, or the problem here, is that as we couldn't stabilize well the balancing robot, if we send any character, it won't be any move, a specific move. As we see in my phone, see that? I will connect to the balancing robot, and the light change. Stop blinking and blink in other sequence. And the light blinks 2 times and then stop 2 seconds, and that's how it goes. Here we can see in the characters that we specify in the programming code, but it doesn't work because the PID is not correct.
So here, as you can see, there are different type of values that we register when we were trying to make this thing to work. We tried several times with the KP, KD, and KI. Like we tried, like, let me check, around 78 times, and we got tired about changing those values one over again. Well, first of all, we tried with the KI with just 0 value due to this one change just by hundreds for changing like this move, as we learned from the Profe Garcia in the videos that that were attached to the assignment. And after that, we tried with the values of the KD, which went from 0 to number 5, but well, not to number 5, just like little numbers. And we tried with the KP, trying to up to 50 in this part, and we didn't see like anything working like properly. And we tried different values with more smooth, and nothing happened really. And trying again with the same parameters, and these ones too. After that, we didn't register anymore. We tried with like crazy values, and we got tired and we didn't even want to register more values about that. So we didn't register more, but I calculate that we did like 53 more with random values, and it didn't work. So it didn't work like properly, like stabilizing. So just the final values are the ones that were in the Arduino. Just that part.